So if you're joining us on the video or anyone else who might be looking at this later, we have just gotten the stair-step system, and the kiddos in class caught up. There was one variation, but it was a legal variation. I could have had negative, 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 or I could have had positive, positive, positive in that first equation, and similar variations along the way. But we should have all ended in some sort of similar system. Now, you guys did not have to end in my stair-step, meaning hopefully you got z equals 0, because that is like a definitive fact. But you could have chosen this other equation with like 10s instead to put in here and divide everything by 10, or you could have chosen one of these other ones. So your stair-step might actually look differently than mine and get the exact same answer. Once again, legal variations. But at the end of the day, as long as mine is valid, and some of you seem to have confirmed it, then we should be able to plug in and get z is equal to, well, we already know that, 0 by, I think Izzy, you were saying just divide by 4, yeah. And if I plug in 0, isn't y just 2/5? And then if I plug in y is 2/5 and z is 0, well, forget that, and that's going to be 2/5. So 3 times 2/5 is equal to 3/2, and I have that. Yeah, that's going to end up being 6/5, right? And this one will be 15 tenths over 12 tenths. So when I subtract, that should be 3 tenths. And I think I'm done. 15 tenths minus 6 over 5, 12 tenths gets 3 tenths. What do you guys think? Give me a thumbs up if you're like, I agree.
No, don't do it. Oh my God. Wait, actually, maybe.
I don't know what we're talking about. I don't know if it's really helpful. So, let's move on. 7.3a. Last night you guys were supposed to work on. However, when you worked on, you might have realized sometimes weird things happen. We just got 3 tenths, 2/5, 0. Question, which picture is taking 3 different 3-dimensional objects, XYZ, 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 3-dimensional, sorry. Yeah. Gotta use 2-dimensional. Think of this, when you have an equation with x, y, z, you can say z is equal to in terms of x, y, similar to y is equal to in terms of x. Y equals an x is a line, it's a sliver, which is technically 1-dimensional, because it's mapping a point to a point going across the first dimension. That's y equals mx plus b, like y with an x. As soon as we technically have like z with an xy, we're taking these 1 dimensions and we're mapping them to other 1 dimensions. So a line to a line, and everything in between is a plane. So technically each of these x, y, z's are planes, as you guys can see, represented by, I mean, these ones are finite. Planes go on forever. But which of these pictures seems to match up with the one that we just did?
The first one.
Because the solution was what?
1 point.
1 point. But do you guys see how now we have 5 different options where we used to have 3? With lines, we had 1 intersection, infinitely many, they're on top of each other, all intersections, but only on that 1 line, or then no intersections, they're parallel or skew or something like that. Now all of a sudden we have, not that you have to draw the picture, I just want you to kind of realize the terms and what they're talking about. Consistent means that there are solutions, maybe I should put it that way. Consistent means that there are solutions, but unlike with lines, it doesn't have to be finitely many, there can be infinitely many. There can be infinitely many. This one is like, hey, what if all 3 of the planes are the exact same thing? This is like our 2 lines are the exact same thing, infinitely many. This one is, okay, they're all intersecting, but they're not the same plane. They just happen to be intersecting in this same line. And this line has infinitely many points as everything expands forever. So there is infinitely many, but it's a different type. This one, the whole plane is shared. This one, the whole line is shared. And then this one, only 1 point is shared. And then these ones, well, these ones are a little weird because they're both none. This one, though, all of them are parallel planes. And this one is, well, blue and yellow do. Pink and blue do. Yellow and pink do. But there's a hole in between. None of them all come together. To that end. Okay, let's talk about what could happen. 1 point, that one's easy. You get an X, you get a Y, you get a Z. And specifically, you probably got a Z equals some sort of number. These ones, there are solutions. Hi, can you leave my room? Sorry, that was fuzzy, so it started coming to my face.
It actually left.
Oh, did it?
It's like out the door.
Such a convenient bugs.
I can't see that.
It looks like a little black fuzzy, you know, like, I don't know, I have a dog who's black, and so it's sometimes black fuzzies are everywhere. So there's a black fuzzy, and then it wasn't a fuzzy. Here we go. Solution. We need a true statement. We need a true statement like 0 equals 0, or 5 equals 5, or 3 equals 3, but the weird thing is Z has to go away, because as soon as we have one Z, one set Z, only one Z, that's only 1 point. So Z somehow goes away, and we end up with some sort of true statement like 0 equals 0 or 5 equals 5. If that ever happens, we need to let Z equal A. And that's what's weird. Because some of you are like, wait a minute, no, one of those ones in last night's homework had an A in it.
37.
An A in the answer field. This is why it had an A in it. A true statement occurred, which meant, okay, there are answers, but there are infinitely many answers, but it doesn't intersect at every single point in space. They don't intersect here, or here, or here, or here. They only intersect here. So we have to somehow make a formula to say, okay, intersection points, but only the ones that are here, not everything everywhere. So to that end, we say, okay, true, cool, infinitely many. Okay, cool, but which ones? And to know which ones, we then go ahead and say, okay, let Z equal A, so A is going to go in that last spot of our three-dimensional point. And we're going to find what Y is in terms of plugging in that A. We plug in a number up here. It's Y of number, X of number. But we're going to plug in A to the Y, and once we plug in A to the Y, now all of a sudden we have an A for Z, something with A's for Y, and we can plug in and get X in terms of A also. We're going to have everybody with little A things. We're going to have everybody with little A expressions. And then over here, well, these guys, we're going to get some sort of false statement. The Z is going to go away, but it's going to be something that is never true. And if it's never true, well, then the answer is just no solutions. There are no intersections with them all. To that end, let's go check out number 37 from last night. That sound good? Because 37, you're like, there are A's. I don't get this. We didn't do this. But I did warn you. I was like, ooh, what if something goes wrong? What will that look like? Was there anything else weird in homework? I have number 8 if you guys want to check it.
That was just kooky.
Well, did you realize 8 was just plug it in and see if it works or not?
Yeah.
But it was just like
How was that
a lot.
How was that cookie? That was kind of easy.
That was like the
It
easiest one.
depends. Well, the directions, I mean, we didn't do it in class, so in that way it's kooky, right?
We did
There
it in the
was-
last homework.
Oh, that's true. But that was two-dimensional, not one.
I just checked Slater and I said,
Why would you expose yourself like that?
Slater?
Honesty. Life's too short.
I
for
prefer
honesty.
blind later.
Although now I can give Izzy a hard time.
About what?
About just going to Slater.
Oh,
How
I
do you
do
go
the
to
same
Slater?
thing.
That's not a resource.
You did.
We got no and yes and no and no. Oh, all of them are no but B? Just kidding.
Yeah.
No and yes and no and no. Why? Well, they could have worked in one and not the others. Did you guys see that A just failed in the first one? Oh, that's nice. It failed in the first one. C failed in the first one. Oh, that's nice. That was fast. And D failed in the first one. Just kidding. Oh, they all failed in the first one. I thought maybe that they would like have you have to plug them into all 3.
I just plugged in.
Yeah, I just plugged in.
Well, I mean, it's nice. As soon as it fails, you can say no. Right? It doesn't work for all of them. But then B, you technically had to check all 3 to make sure it worked for all 3, because otherwise it could have been one of those pictures where it works for 1, it works for 2, it doesn't work for 3. Whoops. Anyway, just let it be. Number 12, your final answer is one of those nice 1-point ones, 2, -3, -2. 2, -3, Oh, and it was already in stair-step row echelon form? Well, mostly it wasn't reduced because it was the 4 and the 6. Still a type of stair-step. Sorry, yeah.
If you have like a plane, so like this is one line, this is this, and then there's like here.
Yeah.
Which way is -2, which way is positive? I'm like,
Oh, is your Z the one coming out or the one going up? Well, it doesn't really matter, I guess. Not. Okay. If you have this, and then this, and then this, is that good?
I guess. Yeah.
Okay. Then I have positives over here.
Yeah.
I have positives up here, and then I have positives out here.
Oh.
Technically, positives are usually towards you when you're showing the three-dimensional form. So it can be tilted different ways, but usually positives are towards you and negatives are away. Some people would make it, this is the hard thing, some people would make this x and y because we're used to x, y, and then this is z, but to be more technical, we put x, y down, and then we have z usually being the vertical one. So z is usually this one, and the x, y is kind of on the ground. And to some extent, if there is that visual, like it is possible that you could have the positives going this way as well. Because if you take your x, y, which is normally right, and then you could put it down at the positives. I think typically in my experience, it's normally towards you as well. Yeah. Okay. Oh, 2 negative, 3 negative. There's already a stair step. That's not bad. Number 22. There were only 2 equations? Can you do stair steps with only 2 equations?
Sure.
Yeah. Can't you do elimination with the x terms and then just get the y? And I mean, technically, most of you just solve.
It's an elimination.
But you could have done stair step. But yeah, there's not a huge point. So back to the, do you have to do a stair step on a 2-system elimination substitution? But number 30. There are 3. Oh, that's tonight's homework. It was not no solution.
Oh.
Number 42. You guys had this one though, right?
Right now.
I wrote that down because
Okay. Number 42, the final answer is, ooh, A's.
that was very confusing.
A's. Why was it confusing? Wait. Just check where it got weird.
That's why I didn't know about the A's back then.
You didn't know about the A's. So you guys would have gone doing your, hey, 1 and 2, do elimination. 2 and 3, do elimination. Cool. 4 and 5, do elimination. But then when you went to go do elimination to get the Z, everything went away. Because if you multiply this by 2, negative 4 and 4 cancel. If you multiply that by 2, 16 minus 16 cancel. You get 0. Well, 2 is 4 minus 4 is 0. That's a true statement. Infinitely many. So check and see what. Well, they made it, I don't know. It's not bad. But instead of showing this, I would have shown it a different way. So let's go ahead. Would you guys rather me play with 37 or 42? To show you how to do. 42 because it's an even?
Yeah, also because 37, we did the elimination, we just didn't get the actual answer.
Okay. So on number 42, let me use that as our weird, not no solution, but infinitely many solution. No solution's easy. You get a false statement and you stop and say, I'm done. So what if, or where did you get stuck in 42? Cool? Here we go. I can make it really nice and gorgeous and pretty like I did yesterday, like writing out steps. Someone help out PJ. But were you able to follow the math that I did when I did the quick one? What you guys were just checking at the beginning of class. Were you able to follow what I was doing, or do you want me to write out, like, eliminate the x terms, 1 and 2? I don't want it to be very fast. Anybody? Do you want it to be pretty, or do you want it to be fast?
Pretty.
Okay. So if I was to do it the pretty way, that's valid. It knows. I get it. I'm going to eliminate the x's in the following. I'm going to eliminate in 1 and 2. Now, hold on. In 1 and 2, I can't just add 1 plus 2 or do 2 minus 1. I need to do negative 2 times 1 plus 2. Does that make sense? So then if I'm eliminating using that, I'm going to get negative 4x minus 2y plus 6z equals negative 8. And then plus 2, I'm just keeping that the same because I see those x's are going to eliminate. So plus 2z equals 10. I'm going to get equation 4 in just 1 second. I'm also going to eliminate x's in equations 2 and 3, multiplying 3, just doubling it, I guess. So I can do 2 plus doubling my 3. There are future notations coming where we like call him R1, R2, R3, but I'm just circling which equation it is for right now. So this one would give me my, keep equation 2 the same, and then double equation 3. Okay, do I get rid of my x terms in both?
Wait a second. Shouldn't it be 9y? Oh, 3? Wait. Oh, 2 times. Oh, sorry. I did 3 times. Oh, sorry.
No, it's okay. I think you were thinking of, were you trying to get rid of something besides x? Maybe like y or z? Okay. No, it's okay. Some people would see this and be like, let's just get rid of the y's because then we have x's and z's. Like there are other human creative license not doing our system at all. Just because I am trying to lead you towards computer programming in some ways and understanding the math that's happening in your calculator when you do matrices. I'm just sticking to one system. But some people would be like, why don't I just multiply that by 3 or negative 3 and just cancel out my y's and have x's and z's. It is a valid approach, just not within our system. I would end up with, what do I got? Negative 2y plus 8z equals 2. And then 6y minus 24z equals negative 6. Good so far? You don't have to agree. If you guys see something, let me know. Even a variation. We can double check and make sure the variation is legal or not illegal. Good? So this is equation 4 and equation 5. What's the system having us do next?
Find z.
By eliminating
A 6 and 2.
the y's. Yeah, the y terms, right? In 4, I need to multiply 4 by 3, yeah? 3 times equation 4 plus 5. Okay, so multiplying this guy by 3. I end up with negative 6y plus 24z equals 6. And 6y minus 24z. Do you see it?
Z equals A.
Yeah. But why? 0,
Because
0,
0.
0. It's a true statement. So true statements means infinitely many, but that doesn't mean all points in space. It still only select ones where they intersect. So then, exactly.
What kind of name is Ashlon?
Her name is Alvin.
Was it Gattaca? There was some Czech movie where Echelon was like the name of like a big parent company that was taking over the world or something. So I don't know where Echelon comes from, Alec, but I've seen it before. Look up in my history of math book, see if it's in there. But z equals a. Wait a minute. What do we do once we have a z equal to? Don't we make our stair step?
Yeah, it's Ashlon.
So I can say z equals a. I mean, that's great and all. We can use some human creative license.
Negative x.
What do you guys want to use?
Negative 8z equals 2.
Oh, this one, the negative 2 one. So that would be y minus 4z. If I'm doing reduced or echelon form, I would be dividing everything by a negative 2. So dividing by negative 2 is a 1y. Dividing by negative 2 is a minus 4. Divided by negative 2 is a negative 1. This is technically what's called reduced row echelon form. And it's what we would have a computer do. Just take the number, divide it. We don't care about the computer's feelings. Like, just go for it, whatever. If it's messy, you'll be fine. But if we have ones in front of everything, then it makes it a lot easier when solving.
So,
I don't like any of those. Oh, the second one's not bad. Want to do the second one? Because I can divide everything by 4. Oh, I don't want that anyway. Yeah, maybe just do the first one. Okay, so we need to divide everything by 2. So we have x plus 1/2 y minus 3/2 z equals 2. If you were to do what we call, once again, reduced row echelon form. That's a little too intense. You could technically just keep that with the 2 and keep that with the negative 2, and then, well, that has to be a. We know z. Oh, wait a minute. Hey. There was a wait a minute and something else in there. I'm sorry, I don't know what that was. We can put the a right here, but wait a minute. Can't we just put in a and get negative 4a added to the other side? I think y is just going to be 4a minus 1 when I plug it in, and solve. Now I need to plug into this guy. Y equals 4a minus 1. I think I would have liked that equation better. That's okay. So we have to end up, if I were you, I'd be pretty careful in simplifying this. This is where it's a little bit messy. Because I have x plus 1/2 times 4a minus 1 minus 3/2 times a. Oh, but wait a minute. It's not too bad, because check it. That's going to be a 2a minus 1/2 minus 3/2 a. I can make this halves to make my life a little bit easier. So I have 4/2 a minus 3/2 a, which would be 1/2 a. You can add this guy to the other side, but oh my goodness, make it easier on your brain. Get him to be 4/2 plus 1/2. It's 5/2. And then just subtract him. So negative 1/2 a.
I hate that.
But how did I just make it easier on myself? Like maybe you guys too. I'm totally being a lazy bum and making it easier on myself. What did I do 2 different times?
You reduced.
I mean, 4/2 does become 2. That's true. But I actually didn't leave it as 2. What did I do?
You made over 1.
To make a common denominator to put it together. And then didn't I do the same thing over here? I made it to be a common denominator to put them together. Like, man, my brain works so much better if I just have common denominators. That's what I'm done. Well, I think it is. I mean, we go double check. And I see a negative 1/2 a plus 5 times 4 minus 1a. That's amazing. Ooh, I can't show you more answers. Anyway, let's go back. We were able to grade the evens from 7.3a. We were able to see specifically where 7.3a got hard, but let's make sure there's not anything else coming in 7.3b that you might want some hints for. Let's make sure there's not anything else coming in 7.3b, because remember, we're doing the next homework, which is the completion of 7.3. Another Google Classroom submission. Alright, here we go. Notes for tomorrow. For tonight. What else could you see besides now? Hold on. Not everything tonight is the messy let z equal a. I'm just trying to do examples of the weirdness that could happen so that you guys are ready. What is weird about the example that you see on the board?
There's a lot of variables.
3 variables.
But there's only 2 of them.
What's the name for that?
Non-square system.
Why is it non-square? Because with 3 variables, how many equations do I have? Yeah. So, I mean, and it's kind of hard because even a 3x4, even 3 equations have like 4 columns, but 1 is the answer column. So if we're looking over here, we have 2 equations, 3 unknowns. I would rather have 3 equations, 3 unknowns. A 3x3 is square rather than a non-square. So the question is just, what if there aren't enough? But if there aren't enough, that just means that there will not be a unique solution. We don't have enough information, but we can still make our own third equation. Why? We can say, okay, fine. Maybe we can't narrow it down to 1 point because there are 2 different planes, which will never intersect in just 1 point. They'll intersect in a line or not at all, or they will be on top of each other and be the same thing. Infinitely many share all points. So we say, okay, fine. There's not enough information to find 1 point. What if z was a? What if z was, okay, it can be any number, but what would y need to be, or what would x need to be in order to make it that specific only where it intersects? So if it's not square, guess what? The answer is make it square with a z equal a. And as soon as the z equals a, well, okay, you're a human. Could we just put in an a, boop, and put in an a, boop, and move all that and do elimination?
Yeah.
Yeah, we could. Or could we follow our system and then plug in? Either one. Just because I'm trying to teach you the system, I'm going to go ahead and do it. And do the system, I'm going to multiply the top equation by -2. I'm going to add it to the second equation. I'm eliminating my x's. Once again, this wasn't the only way. We are humans. There are some creative licenses that we can take. However, I'm trying to get you guys to know my system. And so, if I were to multiply, I would get my, let's see, -4x plus minus 6y minus 6z equals -14 with my 4x plus 18y plus 15z equals 44. Which means I will get my 12y plus 9z equals 30. Now, technically, do I have enough? The answer would be yes. I already have my z equals a, so I don't need to keep going in my system to take an equation that's not there. I have one with x, y, z. I have one with y and z, and I have a z. Technically, some of you guys, in homework, especially last night, you weren't necessarily getting a leading coefficient of 1. You would have had what we call row echelon form, but not reduced row echelon form. I'm just going to prove a point that you can still totally get to solutions. It's just not necessarily how matrices work or computers work. Because they would rather get to be that reduced row echelon form with a 1x, 1y, 1z, so I can plug in and then do the operation and just subtract to get y. Plug in, do the operations, and then just subtract to get x. They would rather have it be a 1, but we're humans, we're all right. We can just take little a and say, oh, I can still plug you in. And y would end up equaling, let's see, -9a plus 30 all over 12. If you were to plug in, subtract the 9a, we usually put the a first, and then divide by 12. Although that's a nasty negative number, I think I might actually, 3 goes into everything, right? 3 times, 4 times, 10 times. I might do 1/4. 10 minus 3a. There's a couple different ways of doing that. That would be our y. Yeah.
For the first equation where it's -4x, wouldn't the 6y be negative?
Yeah, did I not write that? Oh, I did. 18 minus 6 is 12. My negative was, yeah. I did plus and I was like, it's a minus and my erase was too big. It would have made a mess. Good catch though. And then we would take this and we would go throw it into that first equation and say 2x plus 3 times, well, I don't know, this mess, which is a 4, 10 minus 3a, plus 3z, which is 3a, equals 7. And we could get x by itself. I think you guys get the idea at least. And the reason I'm pausing is just because there's one other idea that you might see that might seem kind of confusing. This is actually a really famous or a really common physics formula. It's called the free fall model. What if something only has gravity acting on it? Maybe it's been shot, maybe it's been thrown at an initial velocity, maybe off a hill or a building or from a hole, maybe with an initial height. So only gravity is what is acting on it after it's been thrown or shot. It's called a free fall model. But anyway, they're having you guys kind of look and see how you would solve for the unknowns. So in this one, S is actually kind of like our Y. T is actually kind of like our X. What's missing is the A and the V and the S. What's missing is the acceleration and the velocity and the position. And so they're going to tell us something like in number 48. I think I gave you guys the odd just to help you out. But in number 48, they give us clues like, hey, when T is 1, S is 132. When T is 2, after 2 seconds, it's 100 feet in the air. And after 3 seconds, it's 36 feet in the air. So all of these are for, hey, you're being given T's and S's, technically S of T's. So once again, he's like your Y, these are like your X's. What we would do is take that information and say, so if I plug in 1, I would get 1/2 A times 1 plus V times 1 plus S equals the position. And then I can plug in 2, and 2 times 2 is 4 divided by I get 2a plus 2 times b plus s. Now I'm at 100 feet. I can plug in 3, which is going to be 9 halves a, plus plug in 3b equals 36. Do you guys see a system of equations? Because I do. Ew, I don't like it. Okay, why don't you multiply everything by a 2 to make it prettier? All your fractions are gone. Why don't you multiply everything by a 2 to make it prettier? All your fractions are gone. But they're not x, y, z's. Nah, they're ABS's. It doesn't matter. They're just variables.
ABS,
Acceleration, velocity, and position. Bye, guys.
ABS assistant braking system.
That's ABS, but close. Sounds the same, huh? Bye, guys.